Hey, and welcome to today's daily Leetcode challenge. Today we'll be solving question 1838, frequency of most frequent element. Let's get straight to the drawing phase, or the drawing portion. I wanna read this carefully. The frequency of an element is the number of times it occurs in an array. Well, very obvious. You're given an integer array nums and an integer k, so we're given two parameters. In one operation, you can choose an index of nums and increment its element at that index by 1. So if we're given an array of 1, 2, 3, 4, at any point, I can choose one index, let's say I choose 0, and increment the value by 1, so from 1 to 2. From 1 to 2. At any point, by 1 only. Return the maximum possible frequency of an element after performing at most k operations. Okay, so we can't perform this operation any number of times. We can only perform it k number of times. And what it's really then asking us to do is choose a number that's going to appear most frequently, given that we have this ability to increment some other numbers before that k times. So this definitely will require us to have the numbers in the array arranged in some way where we can, I would say, we can structurally decide which indices to potentially increment. So, for example, if the array isn't sorted and it's given to us in a unsorted fashion, then we will never know which one of these indices to choose and try to increment in order to get to some certain value. For example, let's say that we have this array 1, 4, and 2, and the k that's given to us is equal to 5. Well, to a human eye, it's pretty obvious that you will not be trying to get the most frequent integer to be the 1, because there's no way that we can get either the 4 or the 2 to be equal to 1. Same goes for 2. We can't get the 4 equal to 2, so there's no point in even trying to get 2 to be the most frequent number, because the only value that we will be able to increment is the 1. Well, what about 4 in that case? Well, if we were to try to get 4 to be the most frequent, then we would have to increment this guy 3 times to get to a 4, and this guy twice to get to a 4. And all of a sudden, yes, we see that we can actually have 4 be the most frequent number, and I believe that this is also the first example here, so very, very good to notice that. However, what I'm saying here is that you can see a slight difference between the input array 1, 2, 4 and 1, 4, 2. And the difference is it's not sorted. 1, 4, 2. And what that allows or doesn't allow us to do is know hypothetically which numbers or which indices should I be working with. Here's what an ordered list, here's what sort of insight an ordered list could give me. If I'm looking at a number 1, I know which numbers should be potentially increased, and that's everything to the left of it. Same goes for the 2, same goes to the 4. Basically, this whole long spiel was about me indicating that the first step of this problem should probably be to sort the array. Given that it's not in the constraints, that the input is a sorted array, we should first sort the array. What happens after? Well, after, let's try to visualize potential, some potential examples or problems. I'm going to say that this is a 1, this is a 2, 3, 4, 5, 6, and let's just draw out what a potential input could be. Four. Let's have the rest be 6 and 6. And let's have the number k, and I'm no longer looking at this example, the number k be, this is what, 1, 1, 2, 3, 3, 4, 6, 6. The number k, let's have it be equal to, I don't know, 5, as previous. Well, the way that I would like to visualize this, at least, is as I'm potentially looking at all of the numbers that are possible to be the most frequent, which are 1, 2, basically just all the ones that appear here, 1, 2, 3, 4, and 6. 1, 2, 3, 4, and 6. I'm going to be, I need some sort of, maybe like start and finish. Start being at the start and finish being at the finish. If I'm already looking at a specific number, in this case 1, I know that there are no other potential 1s that I have encountered because 1 is the first number. So I would say that something like some max that I'm keeping track of is currently at 2. Then I could start looking at the next value. I could move end to a new position. This new position indicates also a new number. And what do I do now? Well, the way that I want to visualize this is by having this sort of like this like water, this body of water, taking up some units of unfilled places. In this case, I can see that, I can see that my units of space that the water needs to occupy, this being the total amount of water that I have at my disposal, is going to be 2. And what does this 2 give me? Well, if 2 gives me a max of now 3. Why? Well, because now this one is at a 2, this one is at a 2, and this one is at a 2. So I would have the total frequency of the number 2 pushed up to 3. Now that's my new max. What do I do next? Well, next I would like to step up my potential number to the next possible one, which is going to be 3. Let's look at what a start and an end that's at 3, at the number 3 would look like. Well, I know what sort of body of water would be needed to fill up the extra space, and I can see that that would be 1, 2, 3, 4, 5. Well, there we go. My new max is probably going to be 5. Max of 3 and 5 is 5. Why 5? 1, 2, 3, 4, 5. There we go. With this new approach, what I'm doing is each time I'm setting this boundary, the left and the right, the start and the end, to some position in my input array, which are actually indices, and I'm trying to use up as much k as possible to fill up the space needed. This space will later be called maybe something like div, like difference between the volume that is this and the volume that is actually the current sum. So something like the difference between, let's say, what is in the yellow box versus what is covered in the green. Something along those lines. You see the point though, right? So I'm now, next step, wanting to move up to the next to the next possible value, which is going to be now 4, I see that my start and end are still at, or my start is still at 0, but that could potentially change. Let's see what sort of box I have to fill up if I'm looking at 4 as my potential. Well, it's going to be 1, 2, 3, 4, 5, 6. 6 times 4 is going to be 24. Minus, or no, let's just keep it at 24. And what is the current sum that I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. So my current sum is at 14. So 24 minus 14, I get 10, which means that the space that needs to be filled up is 10 in this yellow, which I know that I can't do with the amount of water I have, 5. So I'll have to compromise. I'll have to start moving up my start potentially, and I can move it up a little bit. I can move it up to here and see and recalculate what my area is going to be. 10 minus the difference of 1 and 4 is just going to be 7. So that's no good too, either. So 7 is no good. I'm going to move up one more time and subtract from 7 another 3, which puts me at a 4. What does this 4 mean? This 4 means that the body of water that I have to occupy is now 1, 2, 3, 4. Can I do this? Yes, but is my max going to be bigger than 5 because now I have these 4 numbers included in there? No, it's not. And so my max keeps up being 5, and I pretty much end up with a max of 5. The later on, you can see that since the difference between the 4 and the 6 is greater than anything here, there's very low chance that anything here is going to be more than 5. And so I'm stuck with these, with the 1, 1, 2, 3, 3 being my max numbers that I can squeeze out. So what this process really is doing, or the analogy that I drew with water, is me having this range, knowing how much this range needs to, or what the volume of this range is, because it's almost two-dimensional over width and over height. And then I know what the current sum is, and the current sum is what I use to figure out how much I need to fill, which would be either greater than or less than the k. Let's try to code this up, see if there's any, see if we can actually put this into code. I'm going to have a couple of variables. I said already that I want the current sum. I want my start equaling and end equal. Oh, well, actually, end I can do, and I can use from my for loop, and let's have a max frequency also equal to 0. For end in range len of nums, I'm going to now what? Well, I have to figure out what my possible max width is, and that would be me having conditionally moving up start to the position, to the lowest possible position, lowest possible valid position. Let's have the width, or the range width, be equal to end minus start plus 1. let's have the height be equal just to the value that we're currently exploring, which is going to be nums of end. We know that the volume is just going to be width times height. And now what? Well, now we have this difference that we care about, which is going to be the current sum, or no, the volume minus current sum. And while this difference is greater than k, I'm going to say start plus equals 1, and also at the same time from current sum remove the nums of start. All good there. Now what? Well, now that we have all of these things in place, we can simply say max frequency is equal to max of max frequency and the width. Now I'm also going to be, I also kind of have to recalculate the width each time, because as start is moving up, so is the width. So I'm going to try to squeeze this guy into the condition here. Let's see. Let's have k is smaller than the difference, which is just volume, which is end minus start plus 1 times this guy. Right? This is my width times height, which is just the volume. So I don't need volume minus current sum here. So this is my diff. Diff is volume minus current sum, and I no longer need this guy. Okay, let's see. With this, so very, very clean and small. Let's see if this works. Max frequent. Might be forgetting something. Max frequency. Width is not defined. Width is not defined. It's not defined because I removed it entirely from. Index out of range. Okay, so I could potentially also be running into an issue where start is leaving its allowed premises. Let's say start is less than len of nums, and what am I doing here? Something is off. I completely forgot about current sum. Current sum has to be equal to the nums of end, because I'm iterating as I'm going up. Okay, closer to the truth. What is the problem here? Let me actually do one more thing. I want to print, no, I don't want to print that. Did I not? I didn't sort. I was talking about needing to have the array be sorted the whole time and forgot to sort. This should work. Let's submit. Awesome. Cool. Well, yeah, hopefully you learned something. Whoa, not well. Not doing too well. I wonder if there's significant difference between what I'm doing and what they're suggesting here with the better solutions or faster solutions. It seems like we're doing sort of the right thing here with the start and the end renamed to left and right. We have a sorted array, and then k is just am I doing an operation that doesn't need to be there? What I don't understand here is where's the while loop and how did they avoid needing to use it entirely? K seems to be like not just the yeah, they're using current sum as if it's in K, which I'm confused about because I mean I totally see what they're doing with the K, but it might just be more hard to read. How are they all avoiding using the while loop is what I don't understand. Okay, this one looked good enough. I wanna understand the situation with the current. I wanna understand this situation. So this is the width. The target is the height. And they're doing everything as I expected. They're watching that the volume minus the current sum, which is just the difference, is greater than k. And if it is greater than k, then they are shifting the start by 1. But how are they able to not have it be in a while loop? Because what if the start needs to be moved up more than just once? What if the start needs to be moved up maybe 2 or 3 times? How are they getting away with that? Also, len of nums minus left. Len of nums minus left. Oh, this is confusing. How does this work for them? How is this possible? Wait, what was the previous thing? It was length minus left. So it's the difference of where left or where the start is finalized minus the largest value. So they're claiming that left is only going to be moved the number of times which is equal to length minus the solution, pretty much. So length minus the solution is equal to left. Left minus the most frequent occurrence of a string is equal to left. How is that possible? What guarantees them that left is only going to be moved up that number of times? Here the condition makes sense. You know what? I'm not going to, oh! There's a solution that's similar. Almost identical, actually. and it's in a good place. Let's instead of trying to understand how that other unintuitive solution works, I'm just going to try to optimize this guy a bit. I definitely don't need to have this here. I don't understand why it wasn't working. I can use the target to look at the number that I want, and start is going to be moved up. Slightly faster, 61%, good enough. This is way more intuitive and easier to understand than the previous one. I don't understand how they were able to get away with the if, and how moving the left boundary up that number of times indicated that that was actually the difference between the solution and the or the total length and the solution. So I'd much rather recommend this. It's way more intuitive. It's visually understandable, which is crucial when you're under stress, like I am right now. So thanks for watching. I'll see you in the later videos. Please like and subscribe. Thank you. Bye.